Hello, welcome to another AQA A-level physics question on circular motion. If you want to try to answer this question yourself, pause the video now. If you've got the answer C, well done. So the graph shows how the velocity changes with time for a simple pendulum moving with simple harmonic motion. Which of the following statements related to the motion of the pendulum is incorrect? Okay, so if we're looking for something that's not true. So we've got various questions concerning acceleration, forces and kinetic energy. Well, because we've got a couple of statements about acceleration, I'm going to draw the acceleration with time as it relates to the velocity. Now, acceleration is equal to the rate of change of velocity with time. And that just means acceleration is equal to the gradient of the velocity time graph. So at this point here, we've got a very large, a very large gradient. So it means we've got a very large acceleration. Here we've got a zero gradient, so we must have zero acceleration. A large negative gradient, a large negative acceleration, zero gradient, zero acceleration, large positive gradient, large acceleration, zero gradient, zero acceleration. So the acceleration will follow my not very well drawn green line. Okay, now let's have a look at these questions. Well, these statements, sorry. The acceleration is at a minimum at t over 4. Well, let's have a look. Here's t over 4. So we can see the acceleration is this green line. Yeah, that's acceleration is at a minimum. The acceleration is 0 at this point. So that is a true statement. The acceleration is at a maximum at t over 2. T over 2, yeah, that acceleration is a maximum. The fact that it's negative just shows which direction the acceleration is in, but it's still at a maximum. So that's a true statement. The kinetic energy is at a maximum of t over 2. So let's have a look at the velocity here. At t over 2, the velocity is 0. Well, if the velocity is 0, the kinetic energy must be 0. So the kinetic energy is certainly not at a maximum. Let's have a look at last question, statement D, and see why it's not true. The restoring force is at a minimum of 3 over 4t. And let's have a look at this acceleration curve again. Well, at 3 over 4t, the acceleration is 0, and because we know force equals mass times acceleration, if the acceleration is 0, then the force on it must be 0. So yes, the force is a minimum at that point. So that statement is true. That is why question C is correct. So if that was useful, subscribe, like and share and watch more of them in the series. A great way to revise. Thank you.